Hey everyone, this is for Revive's practice test for test number 4. In this problem here, it's asking us to find the current before we make any changes to the switch. So evaluate as is. We can tell because this minus sign up there. If it was a plus, it would be asking us to make changes to the switch by opening or closing it and then evaluate the current. But right now, it's just asking us to find the current as is. So let's do that. Coming from here is this 12 volts, right? And then boom, it hits the switch. There's no resistance, there's nothing, and so it's going to short out. If you want to verify why the current is going to be 0, you can do it by V over R, right? And so that'll be 12 volts over how much resistance? It's 0. So that'll be 0 volts. Looking at this one down here, it's asking us to find the current after we've made changes to the switch because of this plus sign right there. So what will happen, we will close this switch here and that'll just be a line. I probably won't even redraw that line because it's a line. And a couple things that we have to look out for throughout this next test when we are asked to make changes to the switch by opening or closing it. First one being, all capacitors are going to be treated as open circuits, and any inductors are going to be treated as shorts. So in this problem here, we don't have any inductors, so we don't have to worry about that, but we do have a capacitor. And so our capacitor now is going to be treated as an open circuit. And what that means is that we can essentially just get rid of this 12 there. We don't need it because current won't be flowing through that path anyway. So let's redraw this whole circuit. Six resistors. And this is an open circuit there. Alrighty, so let's find what this current flowing through here is. And if you guys have been doing it the same way I've been doing it throughout the last test, if you have an energy source like this and you're going up, that's going to give us a negative number. So the current here, V over R, this is going to be negative 12 over the resistance, which is 6 plus 6. And that will give us negative 1. Yep, cool. Alrighty, so this one here, it's asking us to find the voltage after we've made changes to the switch. So just like the last one, the capacitor is going to become open here. This switch is going to be closed there, and so let's redraw this circuit. Okay. And now we have these two resistors in parallel with each other, so we can do this, and that equals to 1.2 mA. Alright, so then we are left, oops. .2. Okay, and so we have two resistors here. We can do a voltage divider on here. Oopsies. So 12 over 1.2, 6 plus 1.2, 12 volts. Okey-doke. This next one here, it's asking us to find the voltage before we make any changes to the switch whatsoever. So nothing's going to happen to this capacitor here because we're leaving the switch as is. So we can basically just pretend that it's not there. We have two resistors here in parallel. We can add those up. So 6 parallel 6 is equal to 3. Let's redraw the circuit. This switch just becomes still that same little switch there. This capacitor, it's still there, but we don't have to worry about it or do anything with it. And here, this is where we are trying to find our V. Alright, so voltage equals what? Voltage equals I times R, and our resistance is 3, and our current coming in is 12 mA, and that gives us 36 volts. Alright, cool. Okay, so we want to find the current before we make any changes to the switch here. With this one, we have an inductor, but we're not going to be doing anything with that because we're valuing the switch before we do anything. And so with this, you see two different resistors here and one there. So we can just do a voltage divider method. You know, we can call this R2, R1. Yeah, okay, so voltage. Amps. And then this is our R2 plus 12 plus 6, and that's equal to 4/3.